Hi guys, so today we're going to be looking at prime factor decomposition. Now, first thing, I want to look at what this actually means. So if we break it down, first thing we need to understand is a factor. So a factor, that's just any number that goes into another number a whole number of times without a remainder, okay? So we can divide 9 by 3 and get 3. We can divide 24 by 8 and get 3. We can divide 12 by 3 and get 4, okay? These are numbers that go into another number a whole number of times. Okay, so moving on from that, looking at a prime number. Now this is a number that has exactly two distinct factors, and they have one in itself. So that's why one can't be a prime number. It doesn't have two distinct factors, it's only got one, which is itself. So our prime numbers are 2, 3, 5, 7, not 9, because as we've seen, it can be divided by 3, 11, okay? So you'll notice that 2 is the only even prime number, and although all the rest are odd, that doesn't mean that all odd numbers are prime, okay? And the last thing we need to understand is decomposition. Well, that's just breaking something down into its components. Now, a component is just a part, okay? So when we're doing a prime factor decomposition, we're breaking down a number into the product of its prime factors, okay? So let's have a look at what this actually looks like. So say we start with 18, okay? Now we're looking for the smallest prime number that goes into 18. We'll choose the smallest prime number, and seeing as though 18 is even, we know that we can divide it by 2. So I'm going to split two branches off my factors. I'm going to have 2, and I know that 2 goes into 18 9 times. Now what I'm going to do is I'm going to close off a branch once I get a prime number at the end of it. I'm going to circle it in red so I know that it's prime, okay? Next thing I've got is my 9, okay? Now I know that 2 doesn't go into 9, but 3 is my next biggest prime number. If I divide that into 9, I'm left with 3. So there we've got a prime number and another prime number. We've closed off all our branches, and if we want to write out our answer, our prime factor decomposition, we're going to do 2 times 3 times 3, and then we're just going to simplify this to 2 times 3 squared, okay? Now let's have a look at 75. 75, it's not even, so we know that 2 won't go into it. What about 3? Well, if we divide 3 into 75, 3 into 7 goes twice, remainder 1. 3 into 15 goes 5 times. Okay, so I'm going to divide it by 3, and 25 is my other branch. I'm going to close off my 3 branch, second prime number. Okay, 25, I know 2 doesn't go into it, and if I know my 3 times table, I know 3 doesn't go into it. So the next biggest prime number is 5. If I divide 25 by 5, I'm going to get 5 because it's a square number, okay? So close off my 5 branch, close off my 5 branch. I've got my 3 prime numbers, got no branches left open. So I'm going to write out my answer, 3 times 5 times 5. Okay, and then simplify it again, 3 times 5 squared. So those are my prime factor decompositions of 18 and 75. Now what I want you to do, you've got 3 questions there, 3 numbers. What I want you to do, just pause the video, have a go at finding the prime factor decomposition of these numbers, simplify it if you can, and then press play on the video in a few seconds. We'll carry on going through it. Okay, so let's start with 24. I know it's even, so I know 2 goes into it, and 2 goes into 24 12 times. I know 12 is even, so 2 is going to go into that as well. Oops, forgot to circle my 2. So I know we're not carrying on with that branch. Got 2 there, and I know that 2 goes into 12 6 times. So close off my 2 branch. And I've got 6. I'm going to divide that by 2. And 6 divided by 2 is 3. Okay. So I've got all my prime factors there. All I'm going to do now, 2 times 2 times 2 times 3. I'm going to simplify that to 2 cubed times 3. Okay. 63, not even, so I can't divide it by 2, but I know that 3 goes into 60, and I know that 3 goes into 3, so I know that 3 goes into 63, and it goes in 21 times, okay? So close off my 3. 21, I know is in my 3 times table. I know 2 doesn't go into it because it's not even, but I know it's in my 3 times table, so I'm going to divide it by 3, and 3 goes into 21 7 times. Okay. And our 7's prime, so I'm going to close that one off as well. So my prime factor decomposition of 63 is just 3 times 3 times 7. And I'm going to simplify that to 3 squared times 7. Okay. And last one, 56, back to an even number, so I'm going to divide it by 2. 56 divided by 2, well, that is 28. Circle my 2. Divide 28 by 2, I get 14. And then divide 14 by 2, I get 7. So I've got all my prime numbers there. I've got 2, 2, 2, and 7. So 2 times 2 times 2 times 7. Simplify that to 2 cubed times 7. Okay. So hopefully you got those 3 right, guys. Have a look through now. See if you can if you did make a mistake. See if you can identify where it is. Make sure you're closing off these branches so you know that you're finished. Make sure you remember which numbers are prime, which ones to close off. Okay. So the last thing I'm going to do, bit of a bigger number now, guys. What I want you to do, just pause the video, see if you can have a go at this one, and then we're going to go through it. Okay. So 375. It's not even, so I know I can't divide it by 2. I'm going to have a look and see if 3 goes into it. 3 into 375. 3 goes into 3 once. 3 goes into 7 twice. Remainder 1. 3 goes into 15 5 times. Okay. So I know that I can divide 375 by 3, and I get 125. Close off my 3. Now 125, not even, so I know it's not going to be 2. Let's try 3 going into it. 3 into 1 doesn't go. 3 into 12 goes 4 times, and then 3 doesn't go into 5. So I know that 3 is not a factor. Let's try the next biggest prime number. It's 5. Well, it ends in a 5, so I've got a good guess that it does go in. I'm just going to see how many times. So 5 into 1 doesn't go. 5 into 12 goes twice, remainder 2, and 5 into 25 goes 5 times. So 5 goes into 125 times. Okay, so close off my 5. And now I've just got this 25 branch to deal with. Well, I know that if I break this down to its prime factors, it's going to be 5 times 5. So all I've got to do now, guys, is just collect all my prime factors. So I've got 3, 5, 5, and 5. So I'm going to write that 3 times 5 times 5 times 5. And I'm just going to simplify that to 3 times 5 cubed. Okay. So hopefully you've got something from that today, guys. Hopefully you've been able to understand what we're doing when we're doing prime factor decompositions. And next time we're going to be looking at how we use that to help us find the lowest common multiple and the highest common factor. Thanks for watching.